Okay guys, I am here for Save Your Day. In this video, I will solve this problem. Search a 2D matrix true. Okay, in the problem, you will receive one matrix and one integer. Your task is return true if the target is inside the matrix and return false otherwise. For example, in the matrix, uh, in this example, we need to find target equal to 5. Target equal to 5 is here, then the output is true. If the target is 20, the matrix have no 20 here, then output will be false. Okay, let's copy the matrix. Copy this. Okay, and put inside the painting. Okay, I have the matrix. The first approach is pretty simple. First approach I've tried is integrate all problems. All problems not. All elements inside the matrix. The first is the naive solution in this sequence. Using this approach, obviously is not a good approach. The code is here. Only set the length of number of rows, number of columns, iterate all elements. If you find, return true. And this approach get TLE, time limit accepted. Is not a good approach because use this approach is O and O2 because you will need search all of the element and no, this approach is not this, is n number of rows multiply number of columns. This is correct complexity. Okay, it's not a good approach because you need to integrate all elements inside the matrix. For improve this approach, I can add 2 lines. Let's go. For improve this approach, I can put 2 lines. If I check the matrix, what I have copy, and pass again. If I check, if I am searching in one row and the target is greater than the last element, obviously the target is not in the row. Then search in the next row. Is the first line. Here, if the target is greater than the biggest element, search in the next line. The second line is if I am in one line, one row, and my target is smaller than the smaller element, obviously our other element is greater than my target. Then stop the search if the target is smaller than the first element, break. Using these 2 lines to cut my search, I get accepted, but the complexity maintain the same because it's possible that you need iterate all elements, even you use the code statement. I get accepted, but the runtime is not too good, around 2 seconds. Then it's out of range inside the graph. Okay, the complexity is the same, but I get accepted. I can improve this search using a binary search. The the metrics don't save. Copy again. The matrix is ordered, is sorted. Each row is sorted and each column is sorted. To search one specific row, I can use only binary search. Then for each row, I check if I can find the element using a binary search, return true, otherwise return false. Using this approach, I get 252 milliseconds is a good improve, and I am in the range, but the approach is for each line, oh, I can iterate our lines and multiply each binary search of one line. We will get log of m by time. Then the complexity is n times log m. It's a good complexity, but I can improve the complexity. Why? How? I can improve using uh, the observation of the metrics. Let's do it, the observation. Here, coop again, and past. If you notice, if I am in one element, like this, I am in the element 9. If I am moved from the right, the number will increase, and for the bottom, and decrease to the top and to the left. Okay, if I start in the first element and use this technique, if the target is greater than my current element, I really don't know if I need to move to the right or to the bottom, because I have two possibilities for moving. But if I start at the diagonal, or in this position, or in this position, let's restart. If I start in this position or in this position, for increase, I have only one movement, this and this. For decrease, I have only one movement, only this. Let's use another column, only this and only this. Okay, then if I need to find, for example, the 5, let's mark the target here. For find the 5 to the element. 5 is less, then move to the top. 5 is less, then move to the top. 5 is greater, then move to the right. 5 is less, then move to the top. And make the same with the another element. 5 is smaller than 15, then move to the left. Is smaller, move to the left. Is smaller, move to the left. Is greater, move to the bottom. Using this approach, start from this element or this element. I have only one path to reach my target, and if you notice, you will move at most n plus m. For example, is in this case is if you start here and your target is here, or in the opposite way, if you start here and you need to reach here. Then, using this approach, you will need at most n plus m, and we will reach one linear solution for this problem. If you check here, it's pretty simple. In this way, I will start I is equal to n plus 1. My approach starts here, n plus 1, n minus 1. Sorry, n minus 1, and in the first one. Okay, guys, using this approach, I get a better time. It's not too much improved from the binary search, but looking the complexity is very different because binary search is n times log m, and in this approach is a linear solution using n plus m time. Okay, guys, thanks for watching. If you like this video, please give me a thumbs up. If you notice some English errors, please comment below, because I am English learning. And see you next time, guys. Bye bye.